Hi, welcome to BC Video 9.5b Part 2, more on the alternating series remainder. Okay, here's one. Approximate the sum of the following series by using its first 6 terms. Now again, just to review, the whole thing to the right of the summation is un, but the part of it that does not include the negative 1 to a power, that's your an. So writing this out, it's 1 over 1 factorial minus 1 over 2 factorial, etc. The series converges by the alternating series test. Remember, you got to make sure your terms are positive, which they are, and decreasing, which they are. And then you got to find the limit as n goes to infinity of an, which sure enough is 0. So we've been asked to use the first 6 terms. So we're going to take the first 6 terms, which is 1 minus a half plus 1/6 minus 1/24 plus 1 over 120 minus 1 over 720. So the sum of the first 6 terms is exactly this. And by the way, you are taking the minuses in there, and with a calculator of some sort, can be a 34, you get 0.63194. By the alternating series remainder, you have that the absolute value of s minus x, s6, which is what we use, is equal to the absolute value of r6, which is less than or equal to a7. Now, a7, of course, would be 1 over 7 factorial, which is 1 over 5040. That works out to be approximately 0.002. So the actual sum lies between our approximation, that 0.63194, plus or minus this 0.0002. And that works out to be a sum somewhere between these two numbers. Now here, this is a much better one. As you can see, this is between 0.6317 and 0.6321. That's a very good approximation. Okay, in 41 through 46, it says use that theorem, the alternating series remainder theorem, to determine the number of terms. Now, the number of terms, that's what they're looking for, the number of terms, okay? So the number of terms required to approximate the sum of the convergent series, so they're telling you it's convergent, with an error of less than 0.001. Okay, so to say that the error is less than 0.001 is to tell you have 3 decimal places of accuracy. Now, there's 2 ways to do this. You can simply start listing the terms and keep going until you get to the first term that is indeed less than 0.0005. Now, I want to point out this has 2 zeros. But remember, if you're going to affect the 3rd decimal place, it's because you're looking at the 4th decimal place and seeing what's happening. So as soon as you get to a term that is less than 0.0005, that means you will no longer be affecting the 3rd decimal place, which means you'll have an answer with an error of less than 0.001. So if this is 3 decimal places, this has to be 3 zeros followed by a 5. And then you would simply ignore that term and all the ones that came after it and just add up the ones you have left. Now, the other way of doing this is if you look at this formula, absolute value of the actual sum of all the terms minus the sum of the first n terms is equal to the absolute value of the sum of the term we didn't use, which is etc., right? Okay, so if we use the first 6 terms to approximate the sum, then the absolute value of R6 is less than or equal to 7, which means the maximum error is less than or equal to, A7. So they want this error to be less than 0.001. You have to solve this. You'd have to find n so that Rn is less than 0.001. Okay, so here's number 42. Let's look at that. Why are these both chapter 4? Did I not just open chapter 9? Isn't this it? Yeah. Okay, so we're looking at number 42. So number 42, use the theorem to determine the number of terms required to approximate the sum of the convergent series with an error of less than 0.001. All right, so first method. List the terms until you get the first term whose absolute value is less than 3 decimal places. Remember, we want with an error of less than 0.001, so we need to go one place further than that. So 3 decimal places means we need 3 zeros and a 5. Okay, so here is our series right here. Okay, so if you actually wrote out the terms, be careful, it does start at 0. -1 to the 0 is positive, 2 to the 0 is 1. 0 factorial turns out it's 1. So you simply go up to, now I don't know how far to go, so I'm just kind of guessing here that I've gone far enough. Okay. So then you rewrite them as fractions, and then here's where you need a calculator to rewrite each one as a decimal. And you're looking for the first time you have a number that's less than 0.001. And this number right here is the first time you have a number that's less than 0.001. So you can eliminate it and all the ones to the right of it, and this will be your approximation. So if you take 1 minus 0.5 plus 0.125 minus 0.0208 plus 0.0026, you will get 0.6224. Now notice I'm going to 4 decimal places because I'd like to round my final answer off to 3. So just give yourself one more. And therefore, we have found out it takes 1, 2, 3, 4, 5 terms to make this happen. But this is a lot of work, and if you didn't have a calculator, you would not want to be sitting there and dividing 1 by whatever 32 times 120 is. Method 2, if they want an error of less than 0.001, that means the maximum error has to be less than 0.001, which means the absolute value of the Rn has to be less than 0.001. And the absolute value of our Rn is, if we take, for example, number 40, where the series is -1 to the n plus 1 times n over 2 to the n. So therefore, the n plus first term will be n plus 1 over 2 to the n plus 1, and we want that to be less than 0.001. So you can solve that on your TI. And you will get n equals 13.